Assalamualaikum and good afternoon, guys. We come to a rather technical and probably involving a lot of chemistry. It is about design considerations, the complexity of functional ingredients, the formulation issues. It's going to be a great case studies. Yeah, how do we formulate using phytosterols? What are the challenges and success stories? And what is phytosterols? The phytosterol is a group of lipid-like compounds found in plants that has been clinically proved to reduce blood cholesterol. In the United States, phytosterol consumption in the range of 2 grams per day has been advised by United States National Cholesterol Education Program. In plants, the role of phytosterols is to stabilize and to regulate the fluidity and the permeability of cell membranes. Similar role is shared by cholesterol in animals. So, what is the learning outcome of this chapter? Number one, we should learn the basic properties of phytosterol. Number two, we have to learn the efficacy and safety of phytosterol. Number three, what are the challenges during formulations? What are the formulation issues? And what do I mean by complexity of an ingredient such as phytosterols? And finally, we're going to see the examples of products that have been successfully formulated using phytosterols. You can expect a lot of chemistry in this class. You should be grateful for taking that food chemistry course. Well, there are more than 200 different phytosterols and related compounds in plant and marine materials. The common phytosterols are like beta-sitosterol, campesterol, and cytostanol. The minor ones are like avinosterol or rhizanol, like you find in rice, phycosterol, and ergosterol. I will give the chemical structure of main phytosterol and cholesterol in class. So you will learn that we have solubility problems with phytosterol. It has high melting point, about 138 to 145 degrees C. So the solubility is really affected, i.e. high melting point is low solubility. But the solution is by using a process of esterification with long-chain polyunsaturated fatty acid that increases the fat solubility. Therefore, we are able to incorporate the esterified long-chain PUFA with phytosterol into fatty foods such as vegetable spreads. You will learn that the solubility of phytosterol esters increases with the number of double bonds as well as with the length of the fatty acid chain attached via a hydroxyl moiety. That is also associated with a decrease in the melting point. So you can imagine when you want to write down the technical requirement for your ingredients, you have to consider all these factors. You have to know what kind of raw materials that you want to order. You will also learn the efficacy of phytosterols, free phytosterol versus esterified phytosterols. You will also know that sterol can be hydrogenated and produce stanol, and both sterol or stanol can be esterified to produce sterol esters or stanol esters. Perhaps the most important knowledge in this class is all about technological challenges of formulating with phytosterols. The challenges are: number one, phytosterols are insoluble in water and poorly soluble in fats and oils. Number two, they are waxy, i.e. they can have adverse effect on sensorial properties of food. And number three, if exposed to extreme thermal treatments, oxidation can occur. Commercially, there can be two types of phytosterols. Number one, what we call Phytosterol Esters, normally in semi-liquid paste with higher fat solubility and lower melting point, therefore easier to formulate in fatty-based foods. Example is beta-sitosterol linoleate. The second type is free phytosterols in crystalline form, with various particle sizes, typically from 30 to 300 microns. These are more stable because they don't have this PUFA moiety. Example would be beta-sitosterol, but the typical problem is with the particle size. So as you can see, we cannot cover everything in this video. This video is very short. It's meant to be a note. You have to come to class in order for us to conclude that to design, you need to study the background of the bioactive compounds or the functional ingredients, the chemistry, the physical properties, etc. And to design also, you need to know, you have to follow the current regulations and laws specific for the target market. There are many more to cover about the use of phytosterols in food and the complexity of these compounds or functional ingredients. You better come to class. See you in class.